Let's have a look at a few navigation questions that you can expect in your pilot exam. And in this video, I'm specifically going to focus on magnetic variation, drift, true tracks, magnetic tracks, compass deviation, and compass headings. So we'll cover most of those examples in this video. All right, so the first one is true track 245 degrees, drift 5 degrees right, variation 3 degrees east, compass heading 242 degrees, calculate the deviation. Now, how I usually approach these questions is I like drawing little diagrams or pictures. I know there's a lot of instructors that are teaching you to you can remember little rhymes or abbreviations and stuff. I just like drawing pictures because I've seen over the years that is something that you can't forget. If you know how to draw a picture once, you can probably know how to draw it more than once. And that helps you to take some of the RAM that your brain needs to remember other more theoretical things instead of remembering little rhymes and abbreviations. Okay, so we start over here. I like to always draw a little cross like this, and then true north will be at the top, east would be there, south would be at the bottom, and I would have west over there. Okay, so this is always the reference that I use when I draw any picture. Alrighty, so true track 245 degrees. Now, like I've said, remember true north is at the top, right? So from true north, 245 degrees track would probably be this line here, roughly. Okay, and that means that from true north to that line over there, it would be 245 degrees. Okay, so our aeroplane is sitting somewhere here on this line. Okay, now before I draw the aeroplane, there's a reason why I don't, because you'll see. The second thing that's being said in the question is that drift is 5 degrees right. Now you always have to remember you're flying on this line, okay, away from this cross here. You're flying on this 245 degree line. Imagine you're sitting in the aircraft and your drift is to the right. So in this case, the aircraft is drifting towards this side as you're flying away. So meaning that the wind is coming from this side, okay? So the wind's coming from here. Let me just get that right. The wind's coming from there. So what do we have to do when we know we have wind? We have to put the nose of the aircraft into wind like this. And that is an extreme example, but there's a reason for it. So you can see I've taken the nose from 245 and I've pointed it in the wind to correct for that drift that we have. So now essentially we've got an angle there between our track and our heading, okay? So in this case, the 245 degrees and the drift 5 degrees right difference over there is going to give us a heading of 240 degrees. Okay, because 245 is there, we've drifted or corrected for drift rather 5 degrees to the left because drift is to the right. So that gives us a true heading. Okay, that's important to remember. It's a true heading of 240 degrees, not magnetic, because this line over here is a true north line. Okay. Then it's saying that variation is 3 degrees east. Okay, now very important, you need to obviously know these terms, variation, deviation, things like that. I'm not going to cover it in this video, but that is important to understand to be able to do these type of questions. That's the more theoretical part of navigation, right? So if we want to have a look at variation and how that influences this picture, variation is the difference between where magnetic north is relative to true north. Okay, so if they're saying in the question that magnetic variation or just variation is 3 degrees east, it means that your magnetic north lies 3 degrees east, which is the side of true north. That's what it is. And as long as you know where to draw that line, you'll never get these questions wrong in terms of magnetic variation. Okay, so that little angle that we have there is 3 degrees. Okay. So that is what variation 3 degrees east means. If it was saying variation 3 degrees west, it would mean that our magnetic north would be to the west of true north on this side of the half. Okay, so now that's magnetic north. So what you have to remember here is that our true heading is 240 degrees, right? So we've measured that from true north all the way around to where our aircraft's nose is pointing there. It's not to that line, that's the track. The nose from there all the way around is 240 to true north. So if we're going to measure from magnetic north around to where the nose is pointing of the aircraft, sorry for my horrible little picture there, from magnetic north to the aircraft's nose is going to give us magnetic heading, okay? Now we know that there's a 3 degree difference there, that over there. So if it is 240 degrees from true north to the nose, then what would it be from magnetic north to the nose? It's 240 minus 3, okay? So that would give us 237 degrees magnetic heading. Heading, why? Because it's going to the nose of the aircraft. Now they're saying that the compass heading is 242 degrees and we need to calculate the deviation. So compass heading is what the compass is reading when we are flying on this magnetic heading. Okay, so they're saying that the compass heading is 242. So although we know that we're on a 237 degree heading, the compass is saying that we're actually a little bit further. So if I can extend this line a little bit further, the compass is saying that we're there on 242 degrees. Okay, which means that compass, if we were to increase from magnetic north to compass heading, it means that, you know, the angle has gone from 237 degrees to 242 degrees. And remember, we can't really play with the heading of the aircraft. We can only change what our reference is here. So for us to go from 237 degrees to 242 degrees, it means that we need to increase this angle from magnetic north to compass north, which means that our compass north is probably going to be there somewhere, right? That would be compass north. And therefore we measure from compass north around to the aircraft's heading or nose, and that angle there from compass north all the way around to the nose of the aircraft is going to give us 242. Okay, so if that from there to the nose of the aircraft is 242, and from magnetic north to the nose is 237, all that we need to go and calculate is what is that difference there. So I mean, that would be 242 minus 237, and that would give us 5 degrees. Okay, now in this case there are two options, 5 degrees west or 5 degrees east. In this case you can see compass north is to the left hand side or to the west of our magnetic north, which means that the correct answer in this case is going to be B, 5 degrees west. Okay, that's how we calculate that. Let's move on to the next one. Okay, the next one says, true track, 070 degrees, variation 30 degrees west, deviation is +1, drift 10 degrees right, calculate the compass heading. So now we need to calculate the compass heading, they're not giving it. Okay, so I'm going to do the same thing as what I always do. I'll just draw my little cross, let's call it the Janus cross, okay, with true north always just at the top, east over there, south at the bottom, west over there. I'll see if I can make this drawing a little bit better. So true track, 070 degrees. Read carefully. What does true track mean? It means that it's your track measured from true north. Okay, so from true north, there's a track of 070 degrees. That means it's that angle over there. That's where we're flying. Okay, that's not where the nose is pointing. That's the track that we're following over the ground. There's a difference. The aircraft can sit on this line and it can be pointing that way or this way because of wind. But the track that we're flying on the ground, or the line on the ground, is 070 degrees true in this case. Then it says variation 30 degrees west. Okay, again, what is variation? It's the difference between true north and magnetic north. Where is magnetic north if it is west of true north? Very simple. It's sitting over there. Remember, anything on this side is west. Anything on this side is east. So if they're telling you variation 30 degrees west, you just go and draw your magnetic north to the west, or the left in this case, of true north, and we know that that angle is 30 degrees. Okay, what does that picture tell us? If we measure from magnetic north to where the track is, okay, that angle essentially over there, that is going to give us 100 degrees. And that would be our magnetic track because it's measured from magnetic north. Okay, then the next thing it says is deviation +1 degrees. Okay, now here you've got to be careful. They're trying to catch you. You actually can't use that information right now. The next piece of information is the one that you should use now, because we're currently working with a track. And the only time that we can work with deviation is if we have a heading. You can't do any deviation calculations if you don't have a heading, because compass deviation is based on headings of magnetic north. So the next thing that we must use is this drift of 10 degrees. Right, okay? So again, we're sitting somewhere on this line and we're drifting to the right. So you can imagine if you're an aircraft sitting on this line here and you're in the cockpit, if your drift is to the right, it means that you're drifting this way, okay? Because of wind that is coming from that side. So clearly there's wind coming from there, pushing the aircraft to the right. So what do? We turn the nose of the aircraft into the wind by the amount of drift that we have. Okay, so we're going to have the aircraft sitting like this, with a nose 10 degrees to the left of our track. Okay, so there's a 10-degree difference. So in other words, what you need to understand here is if you're going to be working with headings, whether that's from true north or from magnetic north, you're going to be using that as your reference line, that little dotted line that I put there on the aircraft. Okay, so if we were to calculate headings, our true heading would be from true north to where the nose is pointing, which is 10 degrees left of 070. So that would actually then be a 060 true heading. And from magnetic north to where the nose is pointing would be 30 degrees plus the 70 degrees minus 10 degrees because we're going to the nose of the aircraft, right? So what does that give us? 30 plus 70 minus 10. So basically from there to where the nose is pointing is going to give us 090 degrees. Okay, so that then is our magnetic heading. Okay, so now we've got magnetic heading, so now we can start working with a deviation of plus 1 degrees. If we have magnetic heading and they say the deviation is plus 1 degrees, anything on the east is plus and anything on the west is minus. That's what you have to remember. Okay, so if we're working with deviation and we need to calculate the compass heading, we invert that thing. Okay, so in other words, in this case it's saying deviation is plus 1 degrees, meaning that compass north is sitting to the right hand side of, or to the east of magnetic north. That's why I said this side is plus. Okay, so there's magnetic north, and a plus 1 degree deviation means that compass north is sitting 1 degree to the east of magnetic north. Remember, don't think that because we're working on this side it's always west. Magnetic north becomes your new 0. Okay, so there's magnetic north, and easterly deviation would mean anything to the right of magnetic north. A westerly deviation would mean anything to the left of magnetic north. So this becomes your new reference if you're working with deviation. You can't use true north anymore. Okay, so this over here is 1 degree. I'm not going to get it in. Let's see. Yeah, 1 degree. I can't put there's the degree sign. And that is now our compass north. Okay, so they want to know from this line to where the nose is pointing, what is that angle? It's simple. Because we know from magnetic north to the nose, it's 90 degrees. Okay, that over there. So that's our magnetic heading. So now just 1 degree less would be our compass heading, right? Because we know that now we're measuring compass heading is measured from compass north, which is this line over here. So it's 1 degree less to the nose of the aircraft than what it is from magnetic north. So therefore we go 090 minus 1, and that is going to equal 089 degrees, which in this case is C. Okay, so that's how you do that one. Let's move on to the next one. See if I've got something here for you. So given true track is 180 degrees, the drift is 8 degrees right, compass heading, now we're getting the compass heading, is 195 degrees, the deviation is minus 2 degrees, calculate variation. Okay. Let's see how we're going to do this one. So again, I'm going to see if I can draw you guys a nice picture here. I'll move this up slightly because now we're going to work in the southern quadrant. So again, true north is at the top, okay? Always. My pictures are always orientated the same, and I suggest you do the same with yours because then you never get confused. So our true track is 180 degrees, which means what? The aircraft is sitting somewhere on this line, pointing downwards, and that's measured from true north, okay? 180 degrees. Okay, so we're somewhere on that line. The drift is 8 degrees right, which means that if you're flying on this line downwards, imagine the airplane's flying like this, you're drifting to the right, as seen from the cockpit. Imagine you're in the cockpit, flying down. If you're drifting to the right, it's that way. Okay, so the wind's coming from this side here. So there's clearly wind from that side. Okay, making the aircraft drift to the right. So what do we do to compensate for wind? If we're on this track of 180, it means that we've already compensated with a nose to be into wind, like that, by 8 degrees. So that means this angle between our track and where the nose is pointing is 8 degrees. Okay, that's the angle there. Then it's saying, oh, wait, sorry, what I forgot is, this is super important. Don't miss this step. I almost did it now. You must do something with this information. We've now gone from a track of 180 and we figured out where the nose is pointing. When you know where the nose of the aircraft is pointing, you've got a heading. Okay, So that is 180 true track at the bottom. We know the nose is pointing 8 degrees to the left of that. That means our true heading is 172 degrees. That's 8 degrees to the left of 180, right? Okay, so imagine measuring from there to south, it's 180, and then measuring from there to where the nose is, it's 180 minus the 8, so that's a 172 degree angle there. I don't want to put it in because then it's too much to write. So that's 172 degrees, true heading, I'll put that in. Why is it true heading? It's because we're measuring from true north at this stage. Okay. Now it's saying that the compass heading is 195 and the deviation is -2. So they're giving us compass heading and they're giving us by how much the compass is deviating from magnetic north. Okay, so now we can put that in. It's saying the compass is saying we're flying on a heading of 195, which if I draw a line, I can put it there and make that 195 degrees. That's where the compass is saying we're flying. Okay, but it's saying that the deviation is -2, meaning that the compass and the magnetic heading there's a difference of 2 degrees between the two. So the magnetic heading must be 2 degrees less than the compass heading. Okay, so which means that our magnetic heading is sitting here somewhere. There's a 2 degrees difference. So if you go from 195, 2 degrees less, it's going to give you 193 degrees. That is our magnetic heading. 193 degrees is our magnetic heading. So now we've got everything, because what do we need to calculate variation? We need two things. We need true heading and we need magnetic heading, because that is what the difference is. That's what variation is. It's the difference between true and magnetic. So we know that our magnetic heading is 193. We know that our true heading is 172. So now we can go 193 minus 172. And if I have my math correct, that is 21 degrees. But okay, well, this one is easy because we only have one option for 21 degrees, right? But let's imagine we had 21 degrees west and 21 degrees east as an example, or as an option in the answers. You have to know whether it's west or east. And again, it's so simple, guys. Look where the magnetic heading is sitting relative to the true heading. So the true heading is 172, and magnetic heading is to the left or the west of our true heading. So that means that the variation is going to be 21 degrees west. Easy as that. Okay, so that's that one. Then the next one, if the compass heading is 282 degrees, variation is 26 degrees east, and deviation is 3 degrees west, what is the corresponding true heading? Okay, let's see if we can get this one right. So again, we draw our little, draw our little cross. It's saying the compass heading is 282. Okay, now if my true north is there, and I've got east over there and west over there, then 282 should be there somewhere. So that's where the compass is saying we're flying. Okay, but remember, 282 is not measured from this. Okay, that's important because this is true north. This that I've put here is a compass heading, meaning it's measured from compass north, but we don't know where that is yet. So that's why I've just put the line as measured from true north, and we'll start filling in the gaps now. So then we go, okay, variation is 26 degrees east. Okay, very simple. Ask yourself the question, what is variation? It's the difference between true north and magnetic north, okay? And if it's 26 degrees east, it means that magnetic north is 26 degrees east of true north. So we can put that in. There we go. Magnetic north. And we know that that angle is 26 degrees because they told us that there, okay? So magnetic north, 26 degrees east of true north. And then it's also saying that the deviation is 3 degrees west. Now look how simple this is going to be, okay? If they say that the deviation is 3 degrees west, it just means that compass north is 3 degrees west of magnetic north. So can you see that when you work with variation, you go from true to magnetic. When you work with deviation, you go from magnetic to compass, okay? So magnetic north in this case was to the east of true north by 26 degrees. Now if you want to go to compass, magnetic north becomes your new reference. Remember, like I've explained in the previous example. So magnetic north is now the reference, and now we say, okay, deviation is 3 degrees west of magnetic north because that's our new reference, which means that compass north is going to be there. And that angle there between compass north and magnetic north is 3 degrees. Okay, so now we've got all our references, true north, compass north, and magnetic north. Look how simple this is. They said that the compass heading is 282 degrees, which means what? This angle of 282 degrees is measured from compass north because it's a compass heading. So from that compass north line all the way around to where our nose is pointing is 282 degrees. Okay, from compass north. What they're asking now is, what is the corresponding true heading? So the only thing that we have to do is we need to go and calculate from true north to where the nose is pointing, what would that angle be? And it's so simple, because we know that this big angle here between true and magnetic is 26, and we know that between compass and magnetic is 3 degrees. So in other words, we need to just get that angle there, and that would be 26 minus 3, which gives us 3 degrees. So, 23 degrees. So that means that angle there is going to be 23 degrees, that angle there. Which means that to go from compass heading to true heading, we add, remember that's a bigger angle than from compass north. So we add 23 degrees. Can you see that you don't have to remember all those rhymes, CDM, V and plus and minus? Just look at the picture. You can see the angle is bigger. If you go from true north to that line, so like this angle here, is definitely a bigger angle than from compass north to that angle there. If you draw a picture, you can't get it right because you're staring at the facts. Okay? Don't have to remember anything. So we add 23 degrees. So that'll give us 282 plus 23, which is going to be 305. Oops. So B is the correct answer. That is what our true heading will be in this case. Okay, so that's that one. Let's see if I've got one more left. Yeah, one more left. Okay. So, variation 6 degrees west, isogonic lines, January 2002. Average annual increase 10 minutes. That's not degrees, that's minutes, okay? Calculate variation in 2005. Firstly, you need to know what is an isogonic line. It's lines on a map or on the earth, okay, that they put on a map that joins places of equal magnetic variation. So wherever you see that line running, looks like a contour line, it means that every single place on that line has got a variation of 6 degrees west. That's what it says. Okay. So now it's saying that the isogonic lines are showing its 6 degrees west variation. In January 2002, there's an annual increase, meaning the variation is becoming more by 10 minutes every year. We need to calculate what is the variation going to be in 2005. So it's very simple. From 2005 to 2002 equals 3 years, right? And we know that over 3 years, it is increasing by 10 minutes, not degrees. It's increasing by 10 minutes annually, which gives us 30 minutes in total, 3 times 10. So there's an increase of 30 minutes total. Now, what you have to know to be able to complete this little thing is that 1 degree equals 60 minutes. So 1 degree variation equals 60 minutes. It's the same thing. Okay, so if I say it's 60 minutes of variation, it's basically 1 degree of variation. Now in this case, we only have 30 minutes of variation. So that would mean it's 0.5 degrees of variation that it has increased by between 2002 and 2005. Now, if we look at the answer options, we've gone from 6 degrees west, 6 plus 0.5 is going to give us 6.5 degrees west. So therefore the correct answer in this case would then be D. Okay, so that's a very simple little example, but it's important that you understand you can go between degrees and seconds. So if this was, let me give you another example. Yeah, if that was 15 minutes, we 3 times 45. So then you'll have to go and get, that would be like a 0.75 degrees. So then this answer would be 6.75. So it's all just a ratio, right? If you know that 1 degree equals 60 minutes, you can calculate 20 minutes, you can calculate 40 minutes, you can calculate whatever minutes it is that you get to the answer, and then implement that into getting the final answer by adding it. If they said it's decreasing, the annual decrease is 10 degrees, then you must subtract it from the initial variation that they give you. Okay, so I think that is it from my side for this video. Yeah, there's nothing left. We've done quite a few. Hopefully this has helped you with magnetic variation, drift, true track, compass headings, compass north. And guys, honestly, this is like a drop in the bucket of what we offer at Exam Revolution. We focus on helping student pilots all over the world pass their flying exams really quickly and easily and efficiently. And we've put together a course that literally covers everything on the online theory syllabus that you need help with. From flight planning to meteorology to clouds to mass and balance to navigation stuff. Every single subject that you need to pass as part of your flight training for PPL, CPL, ATPL, instrument rating. Everything is covered in the online course for a very small subscription fee monthly. So below this video, there's a link. What you can do is click on the link and then go and book a free demo call with one of my team members. And we'll take you through the system. We'll show you exactly what we have to offer. And then you can make the decision for yourself. But if you found this helpful, I can tell you right now that we're going to blow your mind with the rest of the stuff that we also have on the course and in our app. Okay. So if this was helpful, click the link below and then book your free call. And then hopefully we'll see you on the other side.